Okay, I wanted to show you a way to clean up that one derivative problem we talked about. And I don't think from what you said about your teacher that she probably cares, but I wanted to just show you another way you could do this problem to make it cleaner. But again, if this looks really, really nuts and you don't want to do it this way, just completely ignore this. But I thought I would at least show you what I would do. See, if I was given this original problem to find the derivative of, okay, I would try to clean it up. I would try to make this into one fraction. And the way I could do that is if I'm looking at the bottom, I could get a common denominator first. Okay, like I could think of x as x over 1, and then I could multiply the top and the bottom here by x. See, so that would give me a common denominator of x on the bottom. Okay, so I would have x on top, and I would have x squared over x plus c over x on the bottom. Okay, then I would, since I have that common denominator on the bottom, I would rewrite the bottom again as one fraction. I could write that as x squared plus c all over x. Okay, so now my original problem is x over x squared plus c over x. Okay, I could take this another step. And Tyler, honestly, if this looks crazy, don't mess with it. But I just wanted to show you that I could take this last part. See, I have x divided by this fraction. I could think of that as x times that fraction flipped over. So x times x over x squared plus c. Okay, it's kind of like dividing is multiplying by the reciprocal. So instead of x divided by this fraction, it's x times the reciprocal of that bottom fraction. Okay, then I could multiply my x times x together, leaving me with x squared over x squared plus c. It's just that this original problem now, so this original problem is equal to the problem your teacher gave you, but this is now one fraction, and it's so much easier to find the derivative of, and it's going to be cleaner when you do find the derivative of it. Okay, so we could now just find the derivative of this. So y prime, okay, quotient rule, derivative of the top, okay, which is 2x, okay, times the bottom, which is x squared plus c, okay, minus the derivative of the bottom, 2x. So the derivative of that constant would just be 0. So the derivative of the bottom is 2x, okay, times the top, which is x squared, okay, all over the denominator, which is x squared plus c, squared. Okay, it doesn't look really good yet, but it actually cleans up quite a bit because I can use the distributive property here. Okay, that leaves me with 2x to the third plus 2xc, okay, minus, okay, if I multiply these together, the exponents add up, so I get minus 2x cubed, okay, all over x squared plus c squared. Okay, and the nice thing about what we have here is the 2x cubed minus 2x cubed goes away. So my final answer is 2xc over x squared plus c squared. It just looks neater than what we were coming up with. Okay, but again, this final answer, maybe eventually your teacher will want you to kind of play with the original problem to clean it up first. And maybe she never will. But I wanted to at least show you what I was thinking that possibly she may want you to do. But and again, if this looks crazy, crazy ridiculous, I'm sure that you don't need to worry about it at all. Okay, thanks a lot, Tyler. Let me know if you have any questions at all.